So on the previous video, we explained all these questions, and the main idea was that answers are the same thing as solutions, are the same thing as x-intercepts, same thing as roots. We also learned about the quadratic formula. Quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And we also went over one example on how to use the quadratic formula. So you have to have this memorized. You have to be able to write the formula over again, but with parentheses instead of the letters. And then you have to identify a, b, and c from your equation, and then plug in those values in their appropriate spot. And then we went through the simplification process. You always have to do the discriminant value first. And when you do that math, well, actually, let's just come down here. We also talked about the discriminant value and how if your discriminant value is positive, you're going to end up with two real answers, which means that your parabola crosses the x-axis at two locations. If your discriminant is 0, that means that your parabola only touches the x-axis at one location. If your discriminant value is negative, that means that inside the square root of your quadratic formula, you're going to end up with imaginary values. So you end up with no real answers. So if your discriminant is positive, you get two answers. If your discriminant is negative, you get no answers. If your discriminant is equal to 0, you only get one real answer. Now, before moving on to today's actual homework, we need to be able to practice simplifying the last step of the quadratic formula. So once again, guys, listen up. When we apply the quadratic formula, after simplifying the discriminant, after simplifying the square root, sometimes we're going to end up with this situation, and a lot of us don't know what to do from here. Now, obviously, we still have a radical, so you can't really get nice whole numbers or nice integers as answers, but we could reduce this fraction. You see, the idea is this. There's really two terms up on top, the negative 6 and the 4 square root of 3. And the square root of 3 is kind of like a variable, right? So if you have an even number, and another even number, you could reduce all three of them. So we could reduce all three of them. So the 6, the 4, and the other 4 you could reduce by what? By 2. So reduce by 2, and you'll get the 3 right there, the 2 right there, and down here a 2. So that answer is going to become negative 3 plus or minus 2 square root of 3 over 2. So this would be the final simplified answer. Now the reason why we're practicing this is because when we apply the quadratic formula, a lot of times you get to here and you won't get full credit. You have to do that final simplification part. Let's take a look at the next one right here, number 2. So, how about you guys try that one and tell me what we'd get? What's in common? 2. But there's something greater. 3. Something greater. 4. Not 4. 6. So, you want to reduce with the greatest value. So, we're going to reduce all by 6. This by 6, that by 6, that by 6. All by 6. Your final answer will be negative 2 plus or minus 1 square root of 3. And you could put over 1, but that would be unnecessary, right? Anything divided by 1 is that same exact value. So let's not write that. You know what else? You don't even have to put the 1 in front of the radical. So that's your actual answer. Negative 2 plus or minus the square root of 3. Let's go to number 3, guys. Stay with me, please. What could I reduce number 3 by? By 2. So, reduce by 2, by 2, by 2. What's our final answer going to be? Negative 4 plus or minus square root of 3 over 2. So this is, and the reason why I'm practicing just this final step is because this is where students make mistakes. They do all the right work, doing the b squared minus 4ac. They even simplify the radical right, but this last step right here, a lot of students mess up on when it comes to reducing. So let's take a look at the actual assignment. This is a worksheet 9.5 WSP. This is all about the quadratic formula and the discriminant. So up here, it says solve each equation using the quadratic formula. And it also says round to the nearest tenth if necessary. I don't even want a decimal number. If you end up with a decimal, just leave it in radical form. Leave it with the square root. Leave it with the plus or minus square root value. The second half is telling us to find the value of the discriminant only, not to do the whole thing, just the discriminant only. So on the first half, it's all about the quadratic formula. Let me do number 1. So let's first write down the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now, how do we use the formula? You're going to replace the variables with parentheses. So we all, don't be lazy guys, we all need to do that right there. We need to do that right there. And then identify your a value of 1, your b value of 2, and your c value of negative 3, and then plug it in. B goes right here, b goes right here. The a value of 1 goes here, the c value of negative 3 goes there, and the a value of 1 goes right there. Now we always start with the discriminant, the 2 squared minus 4 times 1 times negative 3. So let me do 2 squared first. What's 2 squared?
2 squared is
4. And now how about negative 4 times 1?
Negative 4.
And how about negative 4 times negative 3? Positive 12, right? Now all of this happened inside the square root, so let me rewrite it, or let me write it inside the square root with the plus or minus with the negative 2 on the outside. And we might as well do this 2 times 1, that's just 2 on the bottom. So the next step would be to add 4 plus 12, and we're going to get 16. So we're going to end up with negative 2 plus or minus the square root of 16 over 2. And we look now at the radical, the square root of 16. Could I actually do this? Yeah, so what does it become? It becomes 4. So you really have negative 2 plus or minus, we have a 4 instead of the square root of 16, but it's still over 2. Because the square root of 16 is 4. And now from there, you could actually do your two situations, the negative 2 plus 4 divided by 2, and the negative 2 minus 4 divided by 2. So what is negative 2 plus 4? That's 2. And if you divide that by 2, what do you get? You get 1. So one answer is 1. The other one, you get negative 2 minus 4, that's negative 6. Negative 6 divided by 2, that's negative 3. So those are your two answers, x equals 1 and x equals negative 3. Now what does that mean visually on a graph? That your parabola will cross at 1 and 3 on the x-axis. So do we see how we got the nice, beautiful answers using the quadratic formula?
Yeah.
Is that the smartest way to get the answers? It's not the safest way. It's not the best way. It's probably the worst way. I'm just showing you that the quadratic formula always works. Okay? And not only that, on the instructions it says use the quadratic formula. They want you to use it. They want you to practice it. But if you're taking a quiz or a test, the easier thing to do, ladies and gentlemen, would be to recognize that your a value is 1. So maybe you're able to factor it and rewrite it as x, set it equal to 0, and you think what times what is negative 3 that if you add together is positive 2? So what times what is negative 3 that if you add together is positive 2? Positive 3 and a negative 1, correct? So then you could split it and say x plus 3 equals 0 and x minus 1 equals 0. And you're going to get your two answers. What are your two answers?
X equals
So as you could see, you get the same exact answers, but it's a lot faster to factor, split, and solve if it's factorable. Okay? So if you're taking a quiz or a test, first ask yourself, could I factor this? But right here on the worksheet, even if it is factorable, they want you to practice, Isaac, using the quadratic formula. Okay?